हेलो एवरीवन। आज हम लोग देखेंगे मीन एंड वेरिएंस ऑफ ए रैंडम वेरिएबल। ओके, सी we know that corresponding to every outcome of a random experiment we can associate a real number. This correspondence between the elements of the sample space associated to a random experiment and the set of real numbers is defined as a random variable. If a random variable assumes countable number of values, it is called a discrete random variable. Otherwise, it is known as continuous random variable. Okay. Now, let us see what is discrete random variable. Discrete random variable. Okay. So, let us say that we have a set S of sample space associated with a given random experiment. Then a real valued function x which assigns to each event, let us say each event is belongs to the sample space S, to a unique real number. Let us say that unique real number is x of w, is called a random variable. Okay, so in other words we can say that a random variable is a real valued function having a domain as the sample space associated with a random experiment. Okay, now see if you find difficulty understanding the definition, let me give you an example. Let us say uh, we have tossed 3 coins and sample space of that 3 coins are head head head, head head tail, head tail head, tail head head, head tail tail, tail head tail, tail tail head, and tail tail tail. So to cube, that is 8 sample space, 1 2 3 4 5 6 7 8. Okay, now let x be a real valued function. Let x be a real valued function on S, and that is defined by x of w, that is number of heads in w, and we know this w is a subset of S, that w belongs to S. Okay, now x is a random variable such that we can say that x of head head head. So this is, we have 3 heads, so x of head 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 will be 3. X of, because we are taking number of heads, x of head head tail, we can say here is 2 heads. Similarly, x of head tail head, there are also 2 heads. X of tail head head, there are also 2 heads. X of head tail tail, there is 1 head. X of tail head tail, there is 1 head. X of tail tail head, there is 1 head, and x of tail tail tail, there is 0 heads. Okay, Now, if we say that W denotes the event getting two heads, then set of W would be two heads, that is head tail head head, and head head tail, and X of W, that is 2. Okay. Now, similarly, X associates every other compound events to a unique real number. So, for the random variable X, we have range 0, 1, 2, and 3, right? So, these are actually numbers. So, X can be the range of X would be 0, 1, 2, and 3. We say that X is a random variable such that it assumes value 0, 1, 2, 3. This random variable can also be described as the number of heads in a single throw of 3 coins. Okay. Now, moving forward to our next topic, which is probability distribution. Probability distribution. This X of W should be 3, right? So let us see the probability distribution. See, let us say we have tossed 3 coins simultaneously. Okay, and let X be the random variable defined on the sample space. We have the same sample space, we will use this same sample space. Now, this X of W actually representing number of heads. So it is 2. It is correct. It is 2. Okay, I'm extremely sorry. This will be 2. So let us say we have probability distribution with that sample space, and X of W, let us say number of heads in W, right, which belongs to the set S. Now see, here also we have defined X of W as number of heads, so here number of heads is 2. So we can say number of heads, so we can say that X assumes value 0, 1, 2, 3. So when we say probability of getting X equals to 0, that means, what does it mean? It means that probability of getting, there should be no head, right? Getting no head, that means probability of tail. This is 1 out of 8, so it is 1 by 8. Similarly, probability of X equals to 1, that means probability of getting one head. So we have 3 options. Either we can have head tail, or we can have tail head tail, or we can have tail head. So this is 3 out of 8 possibility. If we say p x equals to 2, that means probability of getting 2 heads. Okay, so it would be probability of head tail, or tail head or head tail head. This is 3 out of 8. And if we say probability of x equals to 3, that means probability of getting 3 heads. That means probability of head. This would be 1 by 8, right? Only one possibility. Now, x cannot assume 4, right? Because we have tossed 3 coins, so maximum number of heads that can appear is 3. So we can write it down in a table. Let us say we have x values that can take 0, 1, 2, 3, and probability of x is 1, 0 is 1 by 8, 1 is 3 by 8, 2 is 3 by 8, and 3 is 1 by 8. Okay, this tabular representation of the values of random variable x and the corresponding probabilities is known as probability distribution. So this thing is your probability distribution. Probability distribution. So I think you got the point. What is probability distribution? Okay. Now let's see some questions so that our concept will be crystal clear. So let's see our first question. Random variable x has the following probability. Distribution is given. Random variable x 0 to 7, 0, 1, 2, 3, 4, 5, 6, 7, and probability of x is given 0, k, 2k, 2k, 3k, k square, 2k square, and 7k square plus k. Find, you have to find number 1 the value of k, number 2 probability of x less than 6, number 3 probability of x greater than equals to 6, number 4 probability of 0 less than x less than 5. So let's see the solution step by step. See, always remember the sum of probability should be 1. Sum of probability should be 1. Okay, so that means number 1 solution would be probability of x equals to 0 plus probability of x equals to 1 plus probability of x equals to 2 up to probability of x equals to 7. This sum should be 1. So probability of x equals to 0 is 0. So write down all this: 0, k, 2k, 2k, 3k, k square, 2k square, 7k square, k is 1. So that means 10k square plus 9k minus 1 is 0. So after taking middle term, we will get 10k minus 1 and k plus 1, that is 0. Now see, k value should be greater than or equals to 0, and that's why you can say k plus 1 cannot be 0. So this means 10k minus 1, it should be 0, that is k is 1 by 10. Okay. Number 2, we have to find out probability of x less than 6. It is strictly less than 6. So let's see the solution. Probability of x less than 6, that should be probability of x equals to 0 to 5, right? So probability of x equals to 1, probability of x equals to 2, probability of x equals to 3, probability of x equals to 4, plus probability of x equals to 5. So this should be 0 plus k plus 2k plus 2k plus 3k plus k square. 1 2 3 4, 1 2 3 4 5 6, 1 2 3 4 5 6. Okay. Now this is k square plus 8k, and we know the value of k, that is 1 by 10. So it would be 1 by 10 square plus 8 into 1 by 10, that is 8 by 10. So it would be 81 by 100. Next value we have to calculate probability of x greater than or equals to 6. So let's find it out. Probability of x greater than or equals to 6. So this means here we have to take equal to sign. So probability of x equals to 6 plus probability of x equals to 7. Okay. This is x equals to 6 is 2k square and x equals to 7 is 7k square plus k. So this would be 2k square plus 7k square plus k. So this would be 9k square plus k. K is 1 by 10, that is this is 9 by 100 plus 1 by 10. So this would be 19 by 100. Okay. Now see, this probability of x greater than or equals to 6, we can find it out also in this manner, that probability of x greater than or equals to 6, this is 1 minus probability of x less than 6. Okay, we can find in this manner also. So 1 minus, we have calculated this 81 by 100, that should be 19 by 100. Remember this. Okay, you can find it out in this manner also. Now we have to calculate probability of x between 0 to 5. So I think you got the logic. Probability of 0 less than x less than 5. So it should be from 1 to 4. So probability of x equals to 1, probability of x equals to 2, probability of x equals to 3, probability of x equals to 4. Right? So this would be k plus 2k plus 2k plus 3k. This would be 8k. K is 1 by 10, so 8 by 10 is the answer. Or you can say 4 by 5. Okay. Now Let's see another question. This type of questions are actually very easy and it is very scoring. You have to know how to solve. That's all. 3 cards are drawn from a pack of 52 playing cards. Find the probability distribution of the number of cards of the number of aces. This thing you have to find it out. So let's see the solution. So let us take, let x denote the number of aces in a sample of 3 cards, because you have taken 3 cards, right? So x denote the number of aces in a sample of 3 cards. And see, we know there are 4 aces, right? There are 4 aces in the pack of 52 cards. Therefore, in the sample of 3 cards drawn, either there can be no ace, there can be 1 ace, there can be 2 ace, there can be 3 aces. So x can take values, x can take values 0, 1, 2 and 3. So we can say that probability of x equals to 0. That means you are taking 0 ace. So this is probability of getting no ace, right? Probability of getting no ace. Okay. So what does it mean? You are taking 3 cards. You are taking 3 cards, but no ace is coming. That means other 3 cards are coming, right? So from, because there are 4 aces, you are not getting any ace. So that means you have taken 3 cards from 48 cards. So 48 C3 divided by 52 C3. Okay. If you calculate this value comes out to be 4324 upon 5525. Now probability of getting 1s. Probability of getting 1s. So that means you are drawing 3 cards, but you have got 1s. That means you are taking other 2 cards from the rest of the cards. So from 4s you are taking 1s, and from 48 remaining 48 cards you are getting 2 cards. So total of 3 cards you have drawn. See, and there are total of 48 cards, 52 cards, 48 plus 4 out of 52 C3, because out of 52 cards you have drawn 3 cards. So if you calculate this value comes out to be 1128 by 5525. Now probability of getting 2s. Probability of getting 2s. So what does it mean? You are taking 2s from 4s and you are getting one other cards from 48 cards divided by total. So 52C3. If you calculate this value, you will get it as 72 upon 5525. Now what is the last one? Probability of getting 3s. Probability of getting 3s. So it is, you are getting 3s from 4s. So 4C3 upon 52C3. That is 1 upon 5525. So what is the probability distribution curve? The probability distribution curve table would be x value, that is 0, s, 1s, 2s and 3s, and probability just now we have calculated, that is 4324 by 5525. This is 1128 by 5525, 72 by 5525 and 1 upon 5525. Okay, so if you add all the probabilities, you will get it as 1. Always remember, total probability is 1. Now let us see another question. 4 bad oranges are mixed accidentally with 16 good oranges. Find the probability. Find the probability distribution of the number of bad oranges in a draw of 2 oranges. Okay, so let's see the solution. It is a similar question as we have discussed above. 4 bad oranges are mixed accidentally with 16 good oranges. Find the probability distribution of the number of bad oranges in a draw of 2 oranges. So you are taking 2 oranges. So x can take value 0 orange, 1 bad orange, 2 bad orange. 0 bad orange, 1 bad orange and 2 bad orange. So let us say probability of x equals to 0. That means probability of getting no bad orange. Probability of getting no bad orange. So what does it mean? That means you have drawn 2 oranges. You have drawn 2 oranges out of 16 good oranges, right? So you have taken 2 oranges out of 16 good oranges by total. So total is 20. 16 plus 4 bad orange, that is 20 orange. 20 C2. So this would be 12 upon 19. So probability of x equals to 1, that means probability of getting one bad orange. One bad orange. So what does it mean? This means that you have taken one bad orange from 4 bad orange and one orange from 16 good orange. So 4C1 multiplied with 16C1. So 112 orange you have drawn out of total 20C2. This value comes out to be 32 by 95. Probability of getting 2 bad oranges. So 2 bad oranges. So that means from 4 bad oranges you have taken 2 bad oranges out of total 20C2. This would be 3 by 95. So what would be our probability distribution table? It would be x, that is 0 bad orange, 1 bad orange, 2 bad orange. And we have calculated probability of x, that is 12 by 19, 32 by 95, and 3 by 95. Okay. See, this type of problems are actually very easy if you concentrate and if you know how to solve this type of problem. It would be very easy and it is very scoring. Now let's see another question. From a lot of 10 items containing 3 defective a sample of 4 items is drawn at random. Let the random variable x denote the number of defective items in the sample if the sample is drawn randomly. Find number 1, the probability distribution of x. Number 2, probability of x less than equals to 1. Number 3, probability of x less than 1. And number 4, probability of 0 less than x less than 2. So let's see the solution. So from a lot of 10 items containing 3 defective items, a sample of 4 items is drawn at random. Let the random variable x denote the number of defective items in the sample. If the sample is drawn randomly, find this thing. So first of all, we have to find out the probability distribution table. From that table, we will solve these questions, right? So you have taken, there are actually 3 defective items and you have taken 4 items. You have drawn 4 items. So X can assume values, that is 0 defective item, 1 defective item, 2 defective item, and 3 defective item. So let us see one by one. Probability of X equals to 0. That means probability of getting no defective item. Probability of getting no defective item. So you have drawn 4 items. Okay. You have drawn 4 items and 10 items. From 10 items, there are 3 defective items. So if you have not drawn any defective items, that means you have drawn from 7 good items, you have drawn 4 items, right? Because out of 10 items, 3 are defective, that means 7 are good. So if you have not taken any defective item, that means you have taken 4 good items from 7 good items. So it would be 7C4 by 10C4. So if you calculate this value, it will be 1 by 6. Now, probability of getting 1 defective item. Probability of getting 1 defective item. So 1 defective item means from 3 defective items, you have taken 1, and from 7 good items, you have taken 3. So 3 and 1, 4. So you have drawn 4 items out of 10C4. This would be half. Probability of getting 2 defective items. Getting 2 defective items. So this would be from 3 defective items, you have drawn 2 defective items, and from 7 good items, you have drawn 2 good items. So 2 plus 2 is 4 out of 10C4. Will be 3 by 10. Probability of X equals to 3. That means 3 defective items. Probability of getting 3 defective items. So this is from 3 defective items, you have taken 3 defective items, and from 7 good items, you have taken 1 good item out of 10C4. This would be 1 by 30. So what will be our probability distribution table? X can assume 0, 1, 2, 3, and probability of X we have calculated 1 by 6, 1 by 2, 3 by 10, and 1 by 30. So let us see probability distribution table, we have find it out. Number 2 is probability of X less than equals to 1. So what does it mean? Probability of X less than equals to 1. That means probability of X equals to 0 and probability of X equals to 1. So it will be 1 by 6 plus 1 by 2. So it would be 2 by 3. And number 3 question is probability of X less than 1. So we have only one option, right? Probability of X less than 1, strictly less than 1. So that means probability of X equals to 0. That means 1 by 6. And number 4 is from 0 to 2. Probability of X is between 0 to 2. So probability of X equals to 1. Only one option, right? So it would be half. So that's how we have to solve this type of questions. And this is actually very easy. Now let us see our next topic, which is mean of a discrete random variable. Okay, so mean of a discrete random variable is given by x bar summation of I equals to 1 to n pi xi. That's all. Okay, this mean of a random variable x is also known as mathematical expectation or expected value. Okay, remember this is very important. This mean of random variable x is also known as expectation or expected value. It is denoted by e of x. In engineering mathematics, it is very useful. If you have frequency distribution, so in case of frequency distribution, in case of a frequency distribution, you have to find the mean by 1 by n, that is total number, f1 x1 f1 x1 plus f2 x2 in this way. Okay, see your x bar. Now this we can write it as f1 by n x1 plus f2 by n x2 in this way. And what is f1 by n? That is probability 1 x1. This is probability 2 x2 in this way. Okay, so if we replace fi by n in pi, we obtain the mean of a discrete random variable. Okay, and this mean of a random variable means mean of its probability distribution. So let us see one question so that it will be clear. In a pair of dice is thrown and x denotes the sum of the numbers on them. Find the probability distribution. Find the probability distribution of x. Also find the expectation of x. So this expectation means, right? You have to find means. See, in a single throw of a pair of dice, the sum of the numbers is 2, 3, 4, 2 up to 12, because the last number would be 6 and 6, so it would be 12. Because you need sum of the numbers. So x can assume values from 2 to 12, right? Because the minimum number can be 1 and 1, that is 2. So x can assume from 2 to 12, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And what would be the probability? So sum 2, that means it is 1 upon 36. Total number of set is 36. And 3, that is 2 upon 36. 4 is 3 upon 36. 5 is 4 upon 36. 6 is 5 upon 36. 7 is 6 upon 36. 8 is 5 upon 36. 9 is 4 upon 36. 10 is 3 upon 36. And 11 is 2 upon 36. 12 is 1 upon 36. So how you got these probabilities? See, if you want to find 12, sum as 12. So see, one phase can be 6 and other phase can be 6. There is only possibility. There is only possibility. One possibility. So 1 out of 36 possibilities. Now if you want to find sum 11, so what are the possibilities? In one phase it can be 6, in other phase it can be 5. In this phase it can be 5 and in this phase it can be 6. So 6, 5 is 11. You cannot get 7, 4, right? Because the maximum number is 6. So 6, 5 and 5, 6. So let's see how 10, sum 10. So 1 is 5, 5, 5, 5. So sum is 10. 6, 4 and 4, 6. So in these three manners you can get sum 10. In all other cases you can find on your own. Okay. Now what is expectation of x? That is pi xi. So what is pi? 1 by 36. What is xi? 2. So p1 x1 plus p2 x2 plus p3 x3. That's how you have to go. So 1 upon 36 multiplied by 2 plus 2 upon 36 multiplied by 3. In this manner you have to write all these values and you will get this value as 252 by 36. Please calculate. You will get this value as this. It will be 7. So this is the mean. Or you can say expectation. Now let us see our next topic, which is variance of a discrete random variable. Variance of a discrete random variable. Now if x is a discrete random variable which assumes values x1, x2 in this manner with respective probabilities p1, p2, then variance of x is defined as variance of x, that is var of x, variance of x, defined as probability of 1 into x1 minus x bar, that is mean square, plus p2 into x2 minus x bar square. In this manner you have to go. So we can write this in short form, that is var of x is calculated as summation I equals to 1 to n pi xi minus x bar square. Now we know x bar is summation I equals to 1 to n pi xi, right? We know this already. And variance of x you can calculate it in this manner. Summation of pi multiplied by xi minus x bar square. Okay. We can find variance in other manners also. Another important formula is variance of x is expectation of x square minus expectation of x whole square. This is also a very effective formula in calculating variance. Okay, remember this. So that means if we break in probabilities, it will be summation I goes to 1 to n pi xi square, this thing is this, minus summation I equals to 1 to n, what is expectation of x? Pi xi square. Okay, so remember this two formula. Now one notable point is, if x is a random variable and a, b are real numbers, then a x plus b is a random variable, is also a random variable with mean ax plus b, with mean ax plus b, and variance as a square variance of x. Okay, now let us see some question so that this topic will be crystal clear to you. Okay, so let us see our first question. Our first question is, a discrete random variable x has the following probability distribution. X is 1 to 7. and P of x is C, 2C, 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 this is 3C, C square, 2C square, and 7C square plus C. Find the value of C. Also find the mean of the distribution. Okay, so let's see the solution. So x is a random variable, discrete random variable, right? So we can say that total probability would be 1. So P of x equals to 1 plus P of x equals to 2 in this manner. P of x equals to 7, this should give 1. So C plus 2C plus 2C, 3C, C square, 2C square, 7C square plus C. This should give 1. That means 10C square plus 9C minus 1. This should give 0. So after taking middle term, you will get it as C plus 1 and 10C minus 1. Okay. Now C should be greater than 0. So this means C plus 1 cannot be 0. So that means 10C minus 1 is 0. That means C is 1 by 10. Okay. Now what is mean? Mean is summation I equals to 1 to 7 xi, probability of x equals to xi, xipi, right? So we can say that this is equals to summation I equals to 1 to 7 I into probability of x equals to I. So x1 is 1 and probability of 1 is C. That's how we have to find out. So it would be 1 into C, 2 into 2C, 3 into 2C, 4 into 3C, 5 into C square, 6 into 2C square, 7 into 7C square plus C. C is 1 by 10. If you put the value, you will get it as 3.66. Okay. That's how you have to solve this type of questions. Now, let us see another question. The question is, two numbers are selected at random without replacement. Without replacement. From the first 6 positive integers. Let x denote the larger of the two numbers obtained. Find expectation of x, that means you have to find out mean, and variance of x. So let's see the solution. Two numbers are selected at random without replacement from the first 6 positive integers. Let x denote the larger of the two numbers obtained. Find this. So you have taken two numbers you have selected from first 6 positive integers. So x can take values 2, 3, 4, 5, 6, because see, x denote the larger of the two numbers. So if you take 1 and 2, larger will be 2, right? So you cannot take 1 here. So probability of x equals to 2. This means probability that the larger of two numbers is 2. Okay. So how can we find it out? We can say that probability of getting 1 in first selection and 2 in second selection. Or it can happen in this way also, getting 2 in first selection and 1 in second selection. Okay, it can happen in this manner also. So you have first 6 numbers. Okay, so probability of getting 1 in first selection and 2 in second selection. So if you have taken 1 in first selection out of 6, then you remained with 5 numbers. So from that 5 numbers you have taken 2. So this would be 1 by 5, because in the question it is given that without replacement. In the second case, getting 2 in the first selection. So if you have taken number 2 in the first selection, that means 1 upon 6, and 1 in the second selection. So 2 has already occurred. So now you have to take the numbers from 1, 3, 4, 5, 6, and you have selected 1. So 1 upon 5 would be 1 upon 15 after calculation. Now probability of x equals to 3. So that means probability that the larger of two numbers is 3. This means probability that the larger of two numbers is 3. So how can you get this? Probability that the larger of two numbers is 3. So there is a possibility that in the first selection you get a number less than 3, and you got number 3 in the second selection, or it can happen in this manner also, getting 3 in the first selection and a number less than 3 in the second selection. So if you get in the first selection a number less than 3, so those numbers is 1 and 2, right? So you have taken 2 numbers out of 6. This is multiplication rule, right? We are applying multiplication rule here. We cannot stop multiplying until unless our first case is completed. Okay, our first case consists of getting our first number less than 3, and in the second row we got the number 3. So in the second row we have taken 2 numbers already, that is 1 and 2, and in the second row we can find out, we have to find out 3 numbers, number 3 out of 5. Because in this case you have taken either 1 or 2. So in the set you have still 5 numbers. If you have taken, let us say, 2, then you have remained with 1, 3, 4, 5, 6. These 5 numbers. So out of that 5 numbers you have taken 3. In this manner, in the second case, let us say we have taken number 3 in the first row. That means we have remained with 5 numbers. And in the second row, we can take 2 numbers, 1 and 2 out of 5. So if you calculate, you will get 2 by 15. Okay. Now probability of x equals to 4. That means probability that the larger of two number is 4. Probability that the larger of two numbers is 4. So what are the possibilities? In the first row, we can take the number less than 4, that is 1, 2 and 3. So you can take any one of the numbers from 1 to 3 out of 6, and in the second numbers you got 4. Okay, larger of the two numbers is 4. So you got 4 number, that is 1 out of 5. Similarly, in the case would be, second case would be, you got 4 in the first row and you got less than 4 numbers, that is 1, 2 and 3 in the second row, that is 3 out of 5. So it would be 1 upon 15. Similarly, you can calculate probability of x equals to 5. That means in the first row you can get less than 5 number, that is 1, 2, 3, 4 out of 6. In the second row you got 5, that is 1 upon 5. And in the second case you got the number 5 in the first row and you got less than number 5, that is 1, 2, 3, 4 that is 4 numbers out of 5 numbers. So if you calculate, you will get 4 by 15. In a similar manner, probability of x equals to 6. So 5 upon 6, 1 upon 5, and 1 upon 6, 5 upon 5. This would be 1 by 3. So what would be our probability distribution? It would be x 2, 3, 4, 5, 6, and probability of x we get 1 by 15, 2 by 15, 1 by 5, 4 by 15, and 1 by 3. We have to find out expectation of x, that is PIXI. So 1 by 15 multiplied by 2 plus 2 by 15 multiplied by 3, 1 by 5 multiplied by 4, 4 by 15 multiplied by 5, and 1 by 3 multiplied by 6. So you will get it as 14 by 3. Okay. Okay. Now I am giving you a homework, that is you have to find out variance of x. Okay. See, you have to apply this formula. Variance of x is expectation of x square minus expectation of x whole square. Okay. By using this formula, you can find out variance and write the answer in comment section. If your answer is correct, I will give a like. So this is our probability distribution, mean and variance. I think ये जो टॉपिक है ये तुम लोगों को समझ में आया होगा. तो आज का टॉपिक इतना खत्म करते हैं. तुम लोग और कौन सा टॉपिक का वीडियो चाहिए कमेंट सेक्शन में बोलो. इसको लाइक करो, शेयर करो और सब्सक्राइब करो. थैंक यू एंड हैव ए गुड डे.